We just got a package from Jack, New York, and Jack mailed in a USB flash drive that needs data recovery. Let's see what Jack said over here. Bad USB port on computer breaks whatever you plug into it. This broke as a result of plugging it into the port. Computer does not detect the drive anymore. So the drive is not being detected because it was plugged in a bad USB port. Let's try to plug the USB flash drive and see if our computer recognizes the drive. I did hear the sound, which means there's some type of communication between the drive and the computer, but nothing is showing.
NorthridgeFix, how can I help you?
Everything looks good on this side. And look at that, I can already tell what the problem is. I can already tell what the problem is. Right here. There's a hole on this resistor here, and we do see the brown marks on the edges. So this resistor is blown. I do not know the value of the resistor, but I can assume that the value may match this one here. Let me measure the resistor and see what value it gives us. We get 17 mega ohms, 20 mega ohms, 24 mega ohms. Now it's fluctuating from OL to values in the mega ohms. Okay, so the resistor is blown. And what's the value of the resistor next to it? I do not know if we can take a measurement with this bad one on there. And it's showing, it's displaying values in the mega ohms also. The value of the blown resistor is affecting the reading of the other resistor, so let's go ahead and remove it. Okay, so let's remove the resistor. Gone. Okay, so it's reading 4 ohms. I believe this is a 402 size. Yeah, this is the same size. And the job is done. Very good. Let's see if the computer will recognize the drive. Let's test. So it's a no-go. It was not detected. Same as usual. Let's go under the microscope, just measure some components, make sure everything is good. Because right now it could be that the controller is bad. If we measure this resistor here, okay, 0 ohms. Let's see if we have a short on any one of the caps here. No short, no short, and no short. So those components are good. You have to understand the board is only made out of a couple of components. The controller is what controls everything. If the controller is bad, the drive is not going to work. Those components tested good. We cannot test the controller. We cannot test the NAND chip. Flip the back. We have one resistor here, which is fairly easy to test. Resistor is reading 331 ohms, which sounds reasonable. Three ohms, 2.23 ohms, not a big deal. 1K, 10 ohms. I mean, for the resistors, we only check if there's anything blown. If something is in the mega ohms or something is OL, then we know the resistor is bad. Okay, so those two are similar in value. And that's it. Those are the only components on the board. And all the components are testing good. So the only thing that could cause this drive not to work or not to function or not to get recognized by the computer is this controller chip here. One last thing I want to do is monitor the flash drive under a thermal cam. And look at this. The chip is getting hot. This is the controller chip, like I suspected. Nothing else is getting hot on the board. So the NAND chip, the controller chip, is what's causing the problem. I do not know if we have any Lexar 16 gigs donor flash drives that we can look at. The problem with controller chips is it's very difficult to find the same controller chip. If we happen to find the same exact drive with the same controller chip, then we will replace the chip and we will be able to recover the data. In case that we cannot find the same exact drive or the same exact chip, then we have to send this off to a data recovery lab and costs are going to go up. We're going to let the customer know. If he agrees, then we send it off to a data recovery lab in case we cannot fix it. If customer does not agree, then we do not recover any files and we ship it back to him. We just got a mail-in for a MacBook 15-inch. It came here for an EFI password reset. Customer said he purchased this MacBook. Everything is working fine, but he was not aware that there was a EFI password. He only realized that after he tried to reinstall the operating system, then it prompted him with the padlock to enter a code. So we're gonna go ahead and reprogram the firmware. This is the EFI chip right here. Okay. Let's go to the programmer's software. We're gonna detect the chip. We're gonna select, and then we're gonna read from the chip. And the chip is being read right now. Done. Let's save the firmware. Save. And let's open the file in the hex editor. And we're gonna clear the password. We're gonna look for the $ SVS. And that's our password right here. We're gonna fill the selection with empty strings, just like that. And we're gonna save it. And then we're gonna load it back into the programmer's software. And good. Okay, and program. And it's done. So now we have to solder that chip back onto the board. Okay, very good. I'm gonna give this to Big Boss to reassemble. Okay, here we have 2 bead spill. Each one is coming from a different state. This one is coming from Ohio. Customer does not mention what's going on or what's wrong. He just have his name, number and email and address. So he did not fill out the mailing form. He just wrote it by hand. The other bead spill is coming from, oh, same thing with the other guy. He did not fill in the mailing form, just handwriting. Spoke to you about replacing the charging port. So it's a charging port. But this one came in 6 million pieces. Okay, this one is solid. The customer did not take this apart. So let's start by working on the one that's already open. And I'll let Big Boss do the honor of reassembling this bead spill. And even the battery is out. Okay, we'll worry about this later. There's too many pieces in here. Too many pieces in here. Oh, the board is right here. So customer took the board out. And the port is broken off here. Does he have that charging port? Did he mill it in? The charging port for the bead spill can be found in compartment number 76 of the 500 ports box. As I recall, I've done a lot of the bead spill and I know we use the charging port from compartment number 76 and we modify it slightly. Sometimes if you cannot find a specific charging port, you can find something similar and modify it. In this case, it's compartment number 76. I'm pretty sure. Let's take a look under the microscope. And yes. So the way we have to modify this is, if you look here, we have 2 legs in the middle and we have 2 legs from the back here. We do not need those 2 legs from the back. And to get rid of them is very easy. We just twist. I'm gonna hold it like this. And we're just gonna twist this. Just a few times. Done. Now we can use this for the bead spill, and this is the same exact charging port as it came with the bead spill. The only difference was the extra 2 legs on the back. We broke it off and that's it. You should be able to find whatever you are looking for in the 500 ports box, but in case you do not, you can always improvise and modify any specific port that looks similar. So let's go ahead and solder that port onto the board. And the port does have broken pads, so we have to fix that. We have to fix this one and we have to fix this. We have the pad here, and this one is not needed. Now we're gonna start by soldering the 2 pins that we see, the second and the third one, so we can hold that port in place. And let's use some of the 559 Flux here. Very good. Okay, so now that we have the port secured in place, we're gonna solder the back. And that will be 1 beads to go, and we still have 1 more to do. We need to run a wire here, and we also need to run a wire here. So let's tin goes. You can see it's running from the pin onto the pad here. Let's just solder one more wire here and we should be good. Done. Now the customer said we do not have to reassemble this because it's going to take a lot of our time. But if Big Boss has time to reassemble it today, I'll let him do it. Otherwise, we're going to ship it back to the customer like this. We're going to also wait on the other bead spill because I'm going to have to wait for Big Boss to come in so he can take it apart. And before we end this video, I have another repair I want to include in this video. This is envelope that came from Florida. Customer sent a Mercedes-Benz key. It looks like one of the older keys. I haven't worked on those keys before. Customer did not include any note. I'm gonna look up his name quick and see what he needs. Button opens and close fell from the board. That's all the information provided. Button that fell off and customer wants it soldered back. Let's take a look at the board. I see 4 legs here. And where's the button? Yeah, the button is 4 legs. We'll solder the button back on. Customer included something else in the envelope inside the bag. I do not know what this is. Let's take a look. What is that? Okay, I see. So customer included the button thinking that this one may work instead of the one that broke. That's what I'm thinking. This one is a lot bigger than the one he sent. Unless there's another button that needs to be soldered on to the board. Let me look. I only see this area here with 4 legs and nothing else. Flip the board. This is where the battery goes and nowhere else to solder the other button that the customer included. Maybe he just included a spare part thinking that that one may work, but all we have to do is solder the button that broke off, and we're going to do this using the soldering iron only. We do not want to apply any hot air. Fume extractor on, and let's do it before I leave home. I'm leaving in about 10 minutes. Okay. And the job is done. Now I'm going to apply more solder using a bigger tip so everything flows nice and neat. And this is the 559 Flux. Okay, it looks much better. Yeah, it does click. I'm gonna hold it next to the microphone and it clicks. And that's it, I'm gonna end it. I hope you enjoyed this video. Don't forget to like and subscribe, leave a comment if you have any questions. And we'll do something else in the next video.